So you are thinking of having a solar power system in your home, but the problem is, how do you select the right one for yourself? Is it 1.5 kVA, 1 kVA, 2.5 kVA, or higher? Today, I want to show you how you can select the most appropriate inverter for your home based on your pockets and what you want to use it for. So stay tuned.
My name is Mohamed Musa. I want to show you how you can select the best inverter for yourself. Now, 1 kVA. What can you carry with 1 kVA? 1 kVA inverter uses one battery, and each battery is 12 volts. While most batteries are 12 volts, they have different current rating. There are some that come with which are 100 amps hour, some are 150 amps hour, 200 amps hour, or 220 amps hour. But you ask yourself, what is an amp hour? Let's use 200 amps for example, since that is what we have in our show. It means you can draw 200 amps of current for 1 hour, or better put, you can draw 10 amps of current from this battery for 20 hours. Now, to know the total power you can draw from the battery, the total power 1 kVA inverter can supply is equal to the amp hour of the battery multiplied by its voltage, which is the amp hour is 200 amp hour and the voltage is 12 volts. It will give you the total power of the battery, which is 2400 watt hour. This is the number of power one battery or 200 amp battery can supply. Now, as you all know, you cannot draw all this power at the same time. It means if you are drawing this 2400 watt hour, it means you are running down the battery. So let's take example. We are using 70% of the total power. So if you are using 75% of the total power, it means the power the usage power will be this 0.575 times the total power. It will now give us 1800 watt hour. That is, to use 75% of the power, that means we are drawing 1800 watt hour. Now, based on that, this, for example, this is the power consumption of an home appliance. For example, a refrigerator have 130 watts, and we have one refrigerator. Maybe in a home you have one refrigerator is 130 amps. Then you have two fans that is 75 amps. You have two TV that is 55 amps, which the total will now give you 110. For ceiling fans 150. You have a decoder of 20 watts, which is one with TV 20 watts. Then you have energy bulb of 11 watts, 6. It will now give you 66 watts. Then your home theater is 50 watts, and you have one, which is still 50 watts. So when you sum together the consumption of your home, for this example now, you have 526 wattage of power. Now, to get the operating hour from that home appliances, now it will now be operating hour will now be the total power that you want to use from the battery time the power consumption. It will now give us that 1800 watt hour divided by the total wattage of the house, which will now give you 3.5 hours. This means drawing power directly from the inverter without solar. It will take you, with this power, with this load, it will take you 4.5 hours to draw this 1800 watt hour from the battery. To use 75% of the from the power, it will take you 3.4 hours. And what this means is that you are not charging the battery. Maybe there is no sun, or for example in the night that the battery is not charged. It means it will take you 4 hours. But in the daytime that the sun is shining, this may not be applicable, because as you are using it, the panel will be charging the battery. So throughout the afternoon, you can use it without issue. It is only in the night that the battery is not charged, you are taking directly from the battery, that will give you these 4 hours. So, but let's say you are not in the night, you are not using the battery, and you are not using the refrigerator. Then if you are not using the refrigerator, you remove the wattage of the refrigerator from the total. Then you divide the wattage hour by what is left. It will give you 4.5 hours. You see, that means you are not using the refrigerator, it will give you 4.5 hour backup time. That is why we were advised to be using the heavy load during the daytime when the sun is charging the battery, so that you can have longer operating hours in the night.
Based on the 75% of the power usage that we talked about earlier on. Now, using only the two fans and the TV, the power consumption of the two fans is 150, and that of TV is 110, which will give you 260 watts. That means if you use only your TV with the two fans, it will give you have about 6.9 hours, which is about 7 hours. It is to tell you that the fewer the load, the longer the operating hours that you have. Now let's talk about 24-volt system, which is 2 batteries. The total capacity of the 2 batteries will be the 200 amps times the number of voltage, which is 24, which will give you 2000, which will give you 4800 watt hour.
In this second example, we will be calculating how many hours you'll be running each appliances. In this case, we have 4 LED lights with load each 10 watts. Then the total will be 40. Then you want to operate it for 6 hours. Then within that 6 hours, it means you'll be drawing total power of 240 watts. Then the second one is tube light, which is 18 watts, and the load, and they are 4 in number. That will give you 72 wattage, and you want to operate that for 5 hours. The total energy we use within that 5 hours is 360. You see. Then the third one is ceiling fan, which have 40 wattage, which the load is the wattage is 40, and we have 3 fans, and the total wattage of the three fan will be 120, and you want to operate it for 8 hours. And that 8 hours, it means you'll be drawing, the fan alone will be drawing total energy of 960. Then the next one is TV, which is 50 watts, and you have just one TV, and you want to use that TV for 8 hours. At that 8 hour, it will use total energy of 400 watt hour. The last one is a refrigerator, and it has a wattage of 160, and you just want free refrigerator, and you want to use it for 8 hours. You want to use it for 8 hours. Now at that 8 hour, you draw the total energy of 1280. Then based on this operating hour, when you sum up together the total energy we use based on this operating hour, you have 3240, which is to tell you that with this 8000, with this 2 battery, that will give you 4800 wattage. You will run this load without any issue, because 2 battery give you 4000, and with this load you have 3240. That means using 2 battery, you can still add 1 or 2 other appliances and to carry it comfortably.
Now I'm talking about the 3.5 kVA 48 volts. Now this 48 volts means 4 batteries, that is 12 volts of each battery times 4, which will give you 48. Now the total energy of the 48 volt system is going to be the 200 amps times 48 volt, which will give you 9600 watts. Now, using the previous home appliances that we use for the calculation, then adding the AC, air condition, to it. Previous example, there was no AC, that's why we have 400 and something watts. Now adding AC to it, AC alone have 746 watts. The total power consumption, including the AC, will now increase to 1272 watts. And based on our calculation of 48 volt system, which give us 9600 watts, to have the backup time, when you include the AC, to have the backup time, the total number of hours the 48 system will give you, including the AC, will now be the total energy backup of the battery divided by the wattage, which is 1272 watts, and this will give you approximately 7.5 hours. And this is the hour it will take you before the system shut down. And as we said earlier, you should use the heavy load during the day for you to have longer backup time.
Thank you for watching, and please feel free to contact us if you have any inquiry or question.